sorry, I call my talk Lives in and Out of Physics because it is a bit of a mixture, as Abby said. It's really in two parts. So first of all, I'm going to talk about some of these who are actually famous female astronomers. And then I'm going to talk a bit about my career, inside and outside physics. And I hope that that sort of comes together with, as Abby said again, with some sort of talks about career choices and options, and we can discuss that a bit. Now, I know it's a bit of a mixture, but the first part actually is a summary or a sort of condensed version of a talk I gave earlier this year, a thing called Astronomy on Tap London. So I'm giving that a bit of an advert as well, because it's run by astro postdocs at UCL, and there's some fantastic astronomy talks on there. They're designed for the general public, but they're often really good, up-to-date astrophysics, in fact. Anyway, I gave a talk on that called Celebrating Women Astronomers, and you can see it on the YouTube channel if you want to see the whole talk. But what I'm going to do today is just focus on the lives, the careers really, of three of the astronomers, and not so much on the science. So the previous talk had more about the science. So there are three women who all worked in the 20th century. They all worked in astrophysics, not physics generally, because I do astrophysics, I do cosmology, so I feel some sort of affinity with them. And yes, they all worked in the 20th century. I don't want really to talk about anybody who's living today or working today. And they were all pioneers and answered really important questions, which you can see here. So this is going to be quite a quick run through their careers. The first one is Cecilia Pyne, who was born right at the beginning of the 20th century. And she actually had quite a good career, quite a good education as a young lady of the time. She actually learnt some science at school, and she went up to Newnham College, which you can see here, at Cambridge, initially to study mostly botany and chemistry. And while she was there, she got really interested in physics and especially astronomy. And she started doing loads of physics courses. And at the end of her studies, she decided that what she really, really wanted to do was research in astronomy. So she started looking around for research posts that she could take up. And then she ran into problems because she was basically told, one, you haven't got a degree, which was a bit unfair because women couldn't actually get degrees at Cambridge at the time. And two, anyway, there aren't any jobs for women in research. You can't be a research assistant or anything like that. You can perhaps do a little bit of teaching, and then of course you'll get married. And she was not deterred by that. She was very surprised, but she determined that she really did want to do research. So she looked around for somewhere where she could do astronomy research. And she came up with the Harvard Observatory, which is a really important institution from the point of view employing women as astronomers and physicists. And here are some of them. They've been working at, or there had been women working at this observatory since the beginning of the 20th century. Initially, they did really mundane work, just cataloguing astronomical images. But over time, some of them started doing their own research using these images. If you want to know more about this, I really recommend this book by Dava Sebel, who this tells you the whole history of this observatory and how important it was for showing that women could actually do serious scientific work. Anyway, Cecilia Pyne managed to get a place working at this observatory and some money to go there. And she was extremely fortunate to arrive at a particular time when a new director had decided that women should actually be allowed to do PhDs. And so she was able to enroll in a PhD, despite not actually having a degree. And she chose for her PhD subject, I'll go back a bit, the question I originally said, which was, what are the stars made of? And she felt that her background made her suitable to tackle this topic. Her supervisors didn't actually think it was a terribly interesting topic because they thought that stars would be made as the same as the Earth, and we knew what the Earth is made of. It's basically rocks, and it's got a lot of oxygen, silicon, aluminium in it, and that's what they thought the whole universe would be made of. What Cecilia showed when she did her analysis was that actually stars are made both hydrogen and helium, which is what we now know to be true. But she was told, well, that can't actually be right. Tone down your thesis. Say that this is a mistake. Your analysis is brilliant, but you can't say you've actually got it right. And so she did. She meekly did what these senior men told her to do, and I think that's a shame, because within a few years, other people had confirmed what stars are made of, and she actually didn't really get the credit that she should have done for this discovery. However, it was recognized that she'd done a very good PhD, and she was able to stay on at Harvard and do more research. And in fact, she spent her whole career at Harvard. Eventually, she became a professor, a head of department, and she published a great deal of very good research, but she always stayed in Harvard. So that's my first very fantastic woman. The second one is 20 years, and this is Margaret Burbage. And she actually did a degree and a PhD in physics, astrophysics at UCL. They would allow women to take degrees. And while she was doing her PhD, she met a theoretical physicist called Geoffrey Burbage and got married. And they then looked for somewhere where they could both do research. And once again, they looked to America as a place to go. And Margaret was essentially an observer. She liked to work hands-on with a telescope. So she started applying for jobs in observatories in America. And she was told she couldn't. Again, women can't work here. The accommodation isn't suitable. You can't be alone at night. There are no jobs for you. And she was absolutely shocked by this, because she'd actually been looking after the University of London Observatory almost single-handed during the Second World War. But as a result, she became a really vocal spokesperson for ending discrimination against women in physics. Anyway, the Burbages got round this problem by Geoffrey applying for observatory roles and Margaret applying for theoretical roles, and then they collaborated and shared out the work. So that was one solution. And they're best known for, or Margaret is best known for, a paper which worked out how all the heavy elements are formed inside stars, which was a very seminal piece of work which set the stage for a lot of future research. And it's normally called B²FH after the names of the authors, which were the two Burbages, Willie Fowler and Fred Hoyle. So Margaret, too, after her initial setback, had a very illustrious career, had a professorship, or several professorships in the United States and the UK, and other leadership roles. So shaky start, but she did well in the end, fantastically well. And my third woman I want to talk about is Beatrice Tinsley. So we would go forward another 20, and she is famous for doing work on galaxy evolution, which is a very hot topic nowadays, but wasn't when she did it. She was brought up in New Zealand, and there's a pattern here. She went to university, did physics, married a fellow physicist who was working at the university, and then looked for a job and was told, you can't work at the same university as your husband. So again, they looked for somewhere where they could both work, and they decided the United States was a place. And her husband, Brian, got a job at the University of Texas quite easily. But Beatrice still struggled to get a suitable role. And in the end, she enrolled in a PhD on galaxy evolution at a different university, hundreds of kilometers away from where Brian was, and had to commute between the two. It was all quite difficult. However, she too, like Cecilia Pyne, did a very brilliant PhD, and she worked out a way of analysing how galaxies evolve from the way that the stars within them evolve, which was quite groundbreaking at the time because people didn't think that galaxies did evolve very much. So that was very good. But after that, she still struggled, unlike the other two women. She couldn't get a permanent job for a long time. She had to move all around the United States to do temporary work. Her marriage broke up because of the stress. She was separated from her children, and she didn't get a permanent post until she was in her late 30s. And when she was 40, she was diagnosed with cancer and she died, which was rather sad. Nevertheless, she leaves behind a huge legacy of work in this very important topic, which is still referred to nowadays. And she published a great deal and has some very fruitful collaborations. So all those women are women who, by their own determination and by their real focus on what they wanted to do, managed to overcome difficulties and make a real contribution to astrophysics. That's, we really should admire them and celebrate them for that. But the big question mark here is because we're going to pause and have a little, do something a little bit different, because those women knew right from when they did their degrees almost what they wanted to do in life, and they were very determined. And they didn't, they had setbacks, but they weren't deterred. But not everybody feels like that exactly, especially when they've first done their degree or when they just finished their PhD. Many people aren't sure exactly what they want to do, whether they want to do research, what they want to do research in. And so at this point, I'm going to ask Abby to do a poll. So I will stop sharing my screen and over to you, Abby.
Oh, hi. Okay, I'm going to do a poll. And okay, I'm going to launch the poll now. So if everyone wants to have a vote, that would be really good. Can everyone see that? Yeah?
Yeah.
Yeah, cool. Thank you. Okay, we got some votes. That's cool. Cool. I will end the poll in a few more seconds. Yeah, so if I end the poll, okay, there's one person who hasn't voted. I didn't.
Well, they don't have to.
They don't have to, yeah. Yeah.
Okay.
Okay, so now I'm going to share the results so everyone can see.
Okay.
Can everyone...
Interesting, yes. Okay, so let's, I'm just going to share my screen and go, in the light of that, I'm going to go back, share my screen again, and...
I'm going to stop sharing. There we go.
Sorry, yeah.
And
can you see that now? Are we back into my... Are we back into my screen all right now?
Yeah, we are. We're good.
Okay, right. So this diagram shows the answer, which is that more than 50% of science PhDs leave research straight away after their PhD. So you are actually pessimistic, and hardly anybody gets to be a professor, although which is perhaps not that surprising because you'd expect some sort of pyramid, and but even the proportion of people who have become permanent research staff for any length of time is quite low. So there are many people who, for whatever reason, decide to leave academic research at different stages of their careers. And this comes from a report from the Royal Society, which is about 10 years old, because it's all I could find. It's for all sciences and both genders, but I think it gives you a reasonable impression of the situation. We know that for all STEM subjects, the proportion of women falls as you go up the academic hierarchy. And so more women are flowing off out of academia at each stage. So that means we all, men and women, but particularly women, are having to make decisions at all these stages about shall we stay in academia or not. And I think that's particularly relevant when you've just finished a PhD, but it's also relevant before you do your PhD and at other stages. And another thing I will point out is that this diagram was only supposed to show flows out of academia, not flows back in, but I think it wouldn't make much difference if you did show the flows back, because there aren't very many, because it's very difficult once you left. And that's another issue you might consider, because of by leaving academia, you're cutting off options. Right, at this stage, I'm going to change tack a little bit again and talk a bit more about my own career in the light of this sort of these figures. And I'm going to do it in a framework of this thing called Hertzberg's two-factor theory, which isn't really a great, fantastic theory. It's a psychological theory. It dates back to the 1950s. But basically, I think it's quite a useful framework for thinking about factors that make you want to do a job or make you want to leave it. And the basic insight that Hertzberg had was that there is one set of factors which are why you do the job, if you like. They're the things that make you feel good. They're the things that, like the women we were just talking about, the fact that they had a fantastic, they really wanted to do science research and they wanted to solve problems and so on. But on the other side, there are some factors that make you dissatisfied with your job, or it just make the job too difficult to do to go on. So to give you some examples, thinking about academic research, the sort of things that motivate you obviously are things like making a contribution to science, solving problems, using your skills that you've learned in your earlier career, all these things. And if you think a bit more widely about other jobs you might do, you might add things like, say if you're teaching or something like that, you're a doctor, you might want you might be very motivated by helping other people. So that's all very nice and positive. On the other side, we've got things like your pay. If you're not paid enough, it doesn't matter how determined you are and how much you really like the job, you may not be able to go on doing it. Your co-worker, job security, the culture of the organization and its ethos, how ethical it is, whether you're just in tune with it, and a whole lot of other things which are fairly mundane, but if they're really difficult for you or just not present, then you may not want to go on doing the job. Now, the three women I just talked about had motivation in spades. They were really had strong focus on almost a vocation for doing their particular scientific research. And so much so that I think some of the bad things about their environment, the hygiene factors as they call them, didn't really matter, or they were able to make compromises and ignore them. So for example, Cecilia Pyne was never paid very much. The women were paid much less than the men, but that didn't worry her too much. On the other hand, she stayed at Harvard all her life. And I think that was partly because it was a comfortable place where women felt safe, were respected. They got the status and recognition that, as you see on the left-hand side. So that outweighed it, the bad things. And for Margaret Burke, she did have problems about job security and some working conditions and so on. But she worked with her husband, and I think they probably gave each other some mutual support. Beatrice Tinsley, I really admire, because I think she had a lot of bad hygiene factors, a lot of discrimination, insecurity, and personal problems. So really, she was completely driven by her own inner motivation. So I admire her. I also want to recognize that there are some external factors that might affect what you think about your job, but I'm not really going to go into those here because there are some things that are not really about the job, but about the wider environment, or things in your life, your wider life, which I'm happy to talk about later, but I'm not going to talk about now. So my career, I'm just using this as an example to, because I know about what I thought at each stage. I'm not saying it's typical or relevant to everybody. But one thing that might be interesting to others is that I left academia. I didn't even do a PhD originally, and now I've come back and I've done a PhD. So, you know, I can see both sides of that. Anyway, first of all, I have to admit that I didn't even do physics. I did maths originally. And as I said, I didn't do a PhD, and I'm going to tell you why I didn't do a PhD. When I finished my degree, like many people, I just didn't know what I wanted to do. I had a vague idea I might like to go on doing research. I knew that if I did maths research, it would be towards applied maths, theoretical physics, not pure maths. But another thing I was quite interested in doing was working in IT, because I'd done some coding during my degree and I quite liked it. And you know, you might be able to earn some money doing this. So I did what at the time I thought was a bit of a cop-out and hedging my bets, and I did an MSc. So we should know the one thing nor the other. And it was quite a strange MSc because it was quite research-based. The dissertation had quite a lot of weight, but also you could do a major and a minor subject. And I did for my major subject quantum mechanics and the minor subject computer science. So completely keeping my options open. So that looks perfect. But halfway through this, I decided that I actually didn't want to go on doing research. And that was because of a wrong balance of these motivators and hygiene factors. I didn't feel that what I'd chosen to do was what I really wanted to do in science. I wasn't fascinated by the problem. Probably my fault. I began to feel I would like to do something wider outside the academic environment, in wider society. And most importantly, I think in hindsight, was the ethos and culture of where I was working. And I'm going into this in a bit more detail because I think that quite a lot of people can feel like this for different reasons. Now, I said that I was doing a fairly research-based master's degree. And because of this, the master's students worked in the same room as the first year PhD students. And next door, there were more PhD students and postdocs. And there were some other women doing master's courses, but there were none doing the courses I'd chosen. And not one single PhD student was female, and not one single postdoc was female. And none of my lecturers were female, and my supervisor was male. And in the end, I just began to feel that this wasn't a place where I fitted in. It wasn't discrimination. It wasn't any inappropriate behavior. It was little things like you walk into a room and people sort of look as if you shouldn't be there. Maybe it was just too many conversations about football and cricket, whatever. I decided that wasn't for me. And I did indeed go and get a job in IT, which is not what I'm going to talk about now, because I'm going to talk about the job that I mostly did after that. So after a bit, I left IT because of this wanting to work for wider society, I think. And I want to talk about what I actually did, because it then began to tick all the boxes on the motivations and hygiene factors. So what I did was called operational research, or OR. The professional society calls it the science of better decision making, but basically it's applying mathematical and analytical techniques to real world problems of organizations or society. And this guy, Patrick Blackett, who I showed here, I put up because he's actually the founding father of OR in the UK. And he was a Nobel Prize winning physicist. He got a Nobel Prize for discovering or detecting the positron. But during the Second World War, he set up a group of scientists who works with the military to solve operational problems, which is where the term OR comes from. And this had three characteristics, this group. It was completely multidisciplinary. He just recruited anybody who seemed to have good problem-solving skills from their science background. It worked very closely with the operational commanders, and it would take on any problem that they threw at the group. Completely new problems, things that had to be dealt with quickly, and things that are often life and death. And it was really successful. And it led to, after the war, OR groups being set up in all sorts of other organizations. And I went to work for the Government Operational Research Service, which is a big employer of all sorts of scientists, mathematicians, statisticians, people who actually did OR in their degree, physicists, anybody who's numerate and can solve problems and be creative. And working for government actually has the added benefit that you can move around different government departments and do different things. So that was great. And this is a little interlude, but just to be topical, the COVID pandemic has spawned all sorts of fantastic research all around the world, but OR has also had a big contribution to make to it, because it really plays to OR's strengths, solving problems quickly, pragmatically, in an evidence-based way, and working with practitioners in the real world. So fantastic. And it was fantastic for me. It ticked all these boxes. And I was working for a good employer, so I had all the right things like job security and good pay. And the only thing that was lacking was I wasn't contributing to science. So that was great. Now, I rose to actually run two different OR groups, and I managed a third group, or led them, which wasn't quite OR, but I still recruited in the same way, people with numerate skills from a variety of backgrounds. And that was great, because I also got in some economists and social scientists and even finance experts. But eventually I moved out of even that group, and I started doing more general management roles. And at that point, I started getting some bad hygiene factors coming in. Now I've gone the wrong way. I don't want to get to that yet. Basically, I've found more deadlines, pressure, working at the top of the civil service. Things are often very pressurized. And I, together with feeling that perhaps I would like to do a bit more science, I went and did a PhD. And immediately I sacrificed my status. I stopped contributing to society so much because I'm doing cosmology and it's a bit removed from helping other people. And I'm paying job security out of the window. But actually, I was in a very fortunate position to be able to take a cut in income. But in other respects, I got a lot of positives from this. I can talk more about the decision to come back and do a PhD at what was actually, a very late stage in my career, and I don't expect to now have a long career in academia. But we can come back to that later. But I hope that I've explained a bit about my own thinking as I changed jobs during the course of my career, and provided a bit of a framework for how you might think about it. And just to finish, this is really simplistic. I thought as part of to lead to discussion, I just put what I see as 3 pluses on each side of the work in academia, do something else, which obviously covers all sorts of other things you could do, which I can expand on a bit more if you want to, but it's highly, highly simplified, this, and doesn't include any negatives, partly because I think a lot of the negatives apply things like long working hours and difficulty with caring responsibilities apply whatever professional career you do. So I haven't put them there. These are the positives. And that's me. Thank you.